So let's talk a little bit about sourdough bread and bread in general. How many of you guys have ever baked a loaf of bread yourselves? All right, so about half of you. So you guys know that bread basically comes down to a combination of flour and water and yeast getting together, hanging out, doing their thing, and then that leavens up the bread, and we get tasty gluten out of it. So sourdough in particular tends to use this thing called a starter. And the way you make a sourdough starter is you get a little bit of water and a little bit of flour, and you set it out. And the yeast that has come along with the flour throughout the milling process, and then also the yeast in the air, get into the flour, and they start reproducing. And when they reproduce and do their thing, they generate little bubbles of carbon dioxide, and that's actually what makes it rise. People who tend to use sourdough, they tend to get attached to their starters if it's tasty. Since there is an environmental aspect to this, you have to have good yeast get into the starter. Once somebody gets a starter that they think is delicious, they tend to nurture it, care for it, and make sure that it stays alive so that they can continue making delicious sourdough bread. But some people take this to an extreme. So this is a photo of the Boudin Bakery. This is a new opening in Santa Rosa. I think that they originally started in San Francisco. They actually had a bicycle procession. The guy in the bicycle helmet is the master baker for the bakery overall, and he's actually kissing the box that has the mother dough in it because this is so special to them. To give you an idea, they've kept this mother dough alive for 160 years, well, over 160 years now, which is pretty incredible. Sourdough starters are tended to be called mother doughs, but in this case, this is more like a great-great-great-great-grandmother dough. They really, really love their mother dough. So this is the opening in, I guess that's Vacaville, California. They got a police escort for bread dough. Like, that's how important this is to these people. It's almost cult-like. Part of it, of course, is pageantry. I mean, if I had kept anything alive for 160 years, I'd make a big deal out of it too. But at the same time, anybody in that area could start an equally tasty sourdough starter because, again, it's environmental. If they're in the same area, they'll have the same yeasts in the air. And if they get a gross one, they can throw that out and start over, and they will hit upon a tasty sourdough starter sooner or later. So let's actually talk about some IT stuff. Why are system images reused so often, and why do we revere golden images so much? We often create our golden images as infrequently as possible, and we reuse them as long as we can manage. To give an example of this, I have seen a golden image that was used for so long that every time it booted, they had to remove a monitoring agent for a monitoring system that had been retired 3 years prior because nobody wanted to go and make a new golden image. Why is this? Usually there is one guy in our office that creates these golden images, and he does it all by hand, and he forgets how to do it in between each time he does it. And so we tend to just be content with the things that we have. And that totally even excludes things like developer machines or cloud environments, things like that. Forget about Docker altogether. Like, this guy tends to be making images for, say, the production VMware environment only. And that leaves us exposed because I grew up as a software developer, sorry. We would tend to develop software on our local machines, on our laptops, and our local environments would be totally different from production because we didn't have access to the same golden images. And that opened us up to risk, and that opened us up to the waste of debugging errors as we deployed things through our various environments. And we can do better than that nowadays. So one question you might have, should we trust this guy? I'll give you a little bit of background. You can do a full background check on me later if you want. My name's Tim Freund. I do cloud engineering at NIC. We do state government web services for over 20 states around the country. I also teach the OpenStack Upstream class before OpenStack Summits. I didn't actually invent that class, but I help teach it and volunteer for it, and it's amazing. If anybody's interested in the process of becoming an open source developer, especially in the OpenStack ecosystem, I'd love to talk to you after this class. My tools of choice tend to be Python, Puppet, and Bash. I started out as a Java developer, and I also do a little bit of Ruby and C#. And there's some contact info. I will repeat that contact info at the end because I love getting rants, comments, complaints. So by all means, reach out. So let's talk a little bit about the industrialization of our food system. This is an advertisement for Magic Yeast. The industrialization of the food system gets a bad rap nowadays. You know, a lot of people don't like glutens, a lot of people don't like GMOs. But overall, the fact that we've industrialized our food system has allowed a lot of us to dedicate a lot of our times to things other than gardening and growing food, and that's pretty fantastic. One of the ways that that's happened is we have yeast packets that we can buy at the grocery store nowadays for less than $1. Get one of those yeast packets, and 30 minutes later, with a little bit of flour and water, and you're creating bread. If you're like me and you have no self-control and a Costco card, you can also buy a 3-pound bag of yeast, and you can use that yeast probably for the rest of your life. It hasn't gone bad yet, so we'll see how far that takes me. Similarly, we have, this is kind of the IT equivalent of that industrialized yeast production. There's a tool called Packer. Who's familiar with Packer? All right, who's familiar with Vagrant? All right, same organization that makes Vagrant also makes Packer. They make a lot of tools. I don't know how they keep producing the number and quality of tools that they do. It's pretty incredible. HashiCorp is the name of the organization. So let's talk a little bit about the architecture of Packer before we get into the details of repeatable builds with it. You get, let's see, see if I can get my pointer. There we go. You have a machine.json file. It can actually be named anything. I tend to name mine machine.json just for consistency between all of my system definitions. It's a plain text file. JSON defines everything else you see in this image. There's the concept of provisioners. I tend to use Puppet a lot because I'm a Puppet guy. There's actually 13 provisioners that are built into Packer today, and of course it's open source and extensible. Windows folks will tend to love the PowerShell one, Ansible, Salt, plain old shell scripts. So like when I define a system, I tend to have a shell script provisioner that installs Puppet, and then I use the Puppet provisioner to install all of my Puppet modules. The other input into the system are disks, and that can take the form of an ISO image, say like an Ubuntu 14.4 ISO, or whatever ISO is appropriate for your operating system. You can also use a disk image to start the process. Packer takes all of that stuff, and it runs it against different builder implementations. And again, we have a wide variety of builders here. AWS, DigitalOcean, OpenStack is a favorite of mine. And then local stuff like VirtualBox and VMware and QEMU and Parallels. The cool thing is, Packer has abstracted away two really annoying aspects of building system images. One, it has automated away the actual key presses that you need to do to install an operating system from scratch. So it basically allows you to start up a small HTTP server that serves up, in Debian or Ubuntu's case, a pre-seed file. In CentOS or Red Hat's case, what's it called? A Kickstart file. So the entire process of installing an operating system from scratch is automated, and then also it's abstracted away all of the differences in creating a new system image on all of the builders that are listed on the screen. So you don't actually have to know how QEMU works. You don't actually have to know how AWS works. As long as you can get your credentials plugged in, it will build those systems for you. Here's a screenshot. We're going to zoom into this screenshot in just a second. I wanted to give you a wide view first, though, just to give you an idea of what a Packer run looks like. Actually, up at the very top in the gray, that's actually me running the R10K process. Who's familiar with Puppet? All right, a couple people. So there's a tool called R10K that's used in the Puppet world that updates your local Puppet modules I tend to run that before I build every time. That way I'm always using the freshest copy of modules available. And then once you start to see the green on screen, that's where Packer is actually executing. Since Packer can run in parallel across multiple builds, it conveniently color codes the output of each thread. We see some red here because I didn't have VirtualBox installed on this particular machine when I ran the build. The green is Docker. You can see it doing Docker things like pulling layers of images. And then down in the yellow, we have the QEMU threads starting. You'll see that it fires up that HTTP port to serve out the pre-seed file that will control the rest of the installation. And it looks for an SSH port that it will eventually try to contact the host on to run the rest of the provisioners. So the from scratch version, it installs an operating system using the ISO, reboots the machine, waits for SSH to appear, logs in with SSH, and then runs the rest of your provisioning steps for you. One of the builders is actually a null builder. So if you have a machine that's already running, you can use the null builder and then execute all of the rest of your provisioners to make sure that your build process works before you put it into your continuous integration system. This is zoomed in a little bit just so that you guys can see some of the details that are going on here. So one takeaway from this, with software-defined infrastructure, we have something that's actually testable and we can automate it because, of course, it's software. How many of us are deploying on bare metal? Okay, so are you guys deploying on bare metal just in production or actually in development too? All right, so we have some folks that are still doing bare metal. Most folks are moving towards more and more virtualization. I know in our organization, the only thing left on bare metal is the database servers. So we're getting to that place where everything is going to be under at least one layer of virtualization. The cool thing about that virtualization layer is that all of our infrastructure from an app developer or app deployer's point of view is behind an API. And that means that we can test our deployment infrastructure and our application infrastructure in just the same way that we would test any other remote API. And as a side note, like that's why I really like OpenStack. I kind of see that as an API for virtualization that, because it's open source, will probably be around for a very long time. And if I wasn't going to deploy on OpenStack because I'm a little bit of an open source zealot, that's why I love AWS. AWS is massive, and they are technology leaders, and they're probably not going away anytime soon. So if I have to pick an API as a software developer to write code against, that's why I personally pick those two. So that's just one thing to think about when you're picking a virtualization platform to run on. Don't think about necessarily is the GUI the most beautiful. Think about, is this an API that I'm going to feel comfortable using for quite a while? So we have APIs. We can run tests against them. We can set up a deployment pipeline for infrastructure that very much matches the deployment pipelines that we're using for development. I was going to ask who's not using continuous integration, but that's an embarrassing question. So who is using continuous integration for software development? Okay, so most everybody is doing that. Anybody who's not and who's interested, feel free to talk to me later, and we can talk through that process as well. The general process, a developer checks code into version control. It runs through some sort of continuous integration and continuous deployment pipeline. In my case, I tend to use Jenkins a lot, but there's all sorts of CI servers out there. And after it builds the software, tests the software, we end up getting some sort of binary package that we can run on our own systems or hand out to clients and users. Since these system images that we're talking about with Packer are just defined with text files, we can do the same thing with them. A sysadmin or even a cron job can check things into version control and can kick off a CI/CD platform or a pipeline that produces a system image at the end of it. So no longer are we waiting on the one sysadmin to generate images for us. Anybody can do it anytime using the same tools that they've been using in their day-to-day software development process. So it sounds like we have all the pieces that we can actually have Jenkins build images for local development and production at the same time. But there are some things we need to worry about. Did anybody attend Justin Searle's talk yesterday? It was a really good talk on writing tests. So one of the things that he talked about a lot, and I would highly recommend you guys go back and watch the video if you can, he talked a lot about execution time of tests and how if you're just getting into automated testing, it's very easy to be comfortable with a long-running test. The problem is there's kind of a geometric increase in overall test suite execution time if we get comfortable with slow-running tests. The same can be said in this case when we're building system images with Packer. So just to install a base operating system from scratch, from a CD image, on my hardware takes about 10 minutes. If every time I checked something in to improve my system build process, I had to wait 10 minutes plus to get a result, I get bored and I go to Reddit and I go to Y Combinator and I don't come back for a half hour or more. And that's not cool. We can work around this limitation though. We mentioned at the beginning, or towards the beginning at least, that Packer will accept not only ISO images, it will accept hard drive images. We can use that to our advantage, and we can set up kind of a layering of Packer builds. On the left, we've got a machine.json, provisioner definition, and the ISO image. And we use that to build a base operating system image. That'll happen, say, like if you're an Ubuntu user, that happens once every 6 months. Or every time they release a point release of the operating system, if you're on the LTS version. We can then put that base image into this next layer, which also has its own machine.json provisioner and then additional patches. If you're a Windows shop, like let's say after Patch Tuesday, this is when you can update your system image automatically to have the latest Windows patches installed. So the next time you spin up a new IIS server, you don't have to go back and install every patch from the beginning of time. And then at the end, that's when you can just layer on top your application code. So you're taking this system image, putting it into the pipeline over here on the right, and just layering app code on top. And that then becomes a very fast process because you're just putting a little bit, kind of the finishing touches on your system image. This is kind of like the poor man's version of Docker's layered file system. So if you've ever pulled a Docker image, you'll see that it pulls down a number of different layers. That's actually like technologically very different than this. This actually is just layering new files on top of an existing file system as opposed to having discrete layers that you can pull apart, like in the case of Docker. One thing to watch out, though, for, if you are targeting a lot of different virtualization environments, you can't run all of these builds on the same node. So there's some CPU instructions that govern how virtualization works in a way that makes virtualization very efficient, but unfortunately only one hypervisor at a time can actually use those bits of the CPU. So you can only run one hypervisor at a time on your build nodes. Because I like Jenkins, we're going to talk a little bit about Jenkins here, of course. The cool thing about Jenkins, you can have multiple slave nodes attached to a master node, and you can label them. So right here in the middle of the screen, you can say we've given this particular slave a label of Packer-QEMU. Build slaves can have multiple labels as well. So this one's labeled Packer-Docker and Packer-VirtualBox ISO. Next up, we can go out and grab a plugin for Jenkins called the Node Label Parameter plugin. And we can use that when we configure our Jenkins jobs. So this is a little snippet of the configuration page inside of Jenkins. 2 parameters here. So I have a project that has multiple machine builds defined in it. So the first one is just the machine name that I want to build. For instance, I've got an Elk machine, a Jenkins machine, a Ceph node, stuff like that. And then the second one is a label. Whatever label gets passed into this job will define what sort of node it can execute on. So if we pass in a value of Packer-Docker, the build will only run on nodes that support the Docker builder. And we can set this up as a matrix job so that kick off the job once, and it will fan out across all possible build label types. So then inside of the actual build shell script, you can see we get the builder label inside of, set as an environment variable. We do a little bit of sed magic to get just the part that comes after the Packer dash in the label. So in this case, if the label was set to Packer-Docker, after we run this little sed, we end up with a builder of Docker. And then we pass that into this build machine script, which allows us to tell Packer to only execute Docker in this particular case. That allows us to run these builds across any number of hypervisors simultaneously and have a consistent build across all of them. And then we can grab a coffee and actually get some real work done. So one of the things that this allows us to do, that guy that's focused on building system images, he can now work on things that customers actually care about. Because here's a tip, like our customers don't actually care about the way that we build system images. They only care about getting the latest and greatest features in our applications. So the more that we can eliminate this sort of grunt work, the more we can actually satisfy our customers. Let's talk about some objections to all of this stuff. Some of you are saying, okay, that's great, but this is going to take a lot of time. And frankly, we've gotten away with not updating our system images for years at a time. Why should anything change now? This is where I go off on a tangent. Has anybody read this book before, Lean Thinking? All right, so this book came out in I think the early 90s. I actually learned about it in about 2008 or 9, I think. There's a company called IMVU, and they did 3D chat. Their actual product is totally inconsequential to this talk. The amazing thing about it was they were the first company that I ran into that talked about using continuous integration and continuous deployment to do production deploys 10 to 100 times a day. Eric Ries is a guy that wrote Lean Startup. He actually came out of IMVU, and that's where he got a lot of his ideas around building lean IT organizations and companies. So one of the anecdotes in there is about, actually all of the anecdotes are about manufacturing, anything from wire mold products all the way up through jet turbines. And the amazing thing about it to me is the fact that like these companies have transformed their operations and trimmed out a lot of waste while dealing with actual like physical equipment. I'll talk about one anecdote in particular. Most of the lean stuff, all of the experts have originated in Japan. A lot of lean manufacturing is called the Toyota production system. And there was a company in Charleston, South Carolina, the Jacobs Chuck Company, and they were slowly going out of business, and they had to turn life around for themselves. Through a bunch of convincing, they finally got some Japanese consultants to come over and check out their organization. One of the things that they had worked on before the Japanese had come was trying to streamline the flow of material through their organization. And the consultants arrived, and they were completely disappointed. So one of the contexts of Lean is to get continuous product flow from your door through your plant out your shipping dock. And they did not see that in the production cells at the Jacobs Chuck Company. So they arrived at about lunchtime, and they immediately wanted to start moving heavy equipment around the plant to streamline the flow. Because of union contracts, the engineers shrugged and were like, no, we don't move anything at this hour. Like, this hour is for eating. So we're going to go back to eating if that's okay with you. That was not acceptable because in the eyes of these consultants, waste is a killer and a soul crusher, and you cannot like stand idly by while there is waste in your environment. So they went and found giant pry bars and crowbars and started moving this heavy equipment inch by inch to make a point that like we cannot wait. Like we either get started now or you are doomed. The amazing thing to me out of all that is like moving heavy equipment is kind of a big deal. My family is a family of printers and die cutters. This is one of the smallest presses I've ever seen. This is not one of our presses. This is a Heidelberg windmill. Even a tiny press like this involves three-phase power, so you got to get an electrician involved every time you move it. This is the smallest press that I've seen in our shop. It's a Heidelberg cylinder printing press in this case. we actually have to hire somebody to come in with a special forklift to move this. So this is a big deal to move this sort of equipment, and these consultants wasted no time, and even if they had to move it inch by inch manually, they started moving this heavy equipment at the Jacobs Truck Company. Meanwhile, we're in IT, we deal with text files, we have version control, and still I see a lot of people reject the idea of making continuous improvements in the way that we do things. We can always roll things back. Like, we've got it really easy. We can do incredible things with the tools that we have today. We just need to get comfortable actually taking some risks and experimenting and doing it. So I mentioned the Lean Thinking book. Lean Thinking is a great book, but it is a super dense book. It took me a very long time to get through it, and I almost stopped several times. If you're not into that sort of book, check out this guy. This guy's named Paul Akers. He runs a company called FastCap in the state of Washington, and they build things to streamline the work of woodworkers and carpenters. His business was fantastic. His bank loved him, but he got bit by the lean bug, and he invited some consultants in. And again, the consultants said, "Your company is full of waste. Like, it's great that you can afford this giant warehouse of inventory, but every bit of this inventory is waste, and it causes rework." Paul dove in, and he actually went to Japan for a couple months, learned Lean, came back, tried to get Lean instituted inside of his organization, and it failed. And the conclusion he came to was that because Lean was not like a thing that people were excited about, people were only making Lean improvements when he was around to drive the change. And his epiphany was, we need to make Lean fun, we need to allow people to fix what bugs them, and then we need to remember the 8 wastes. You should check this guy out on YouTube. He is crazy. He even has a video about how to clean bathrooms in a Lean fashion. So every morning at the FastCap plant, they all pitch in and they clean the plant together. There are no janitors employed at FastCap, and one of the rotating duties is literally cleaning the toilets. And this is a CEO that actually cares, because not only does he regularly clean the toilets in rotation, but he has made videos of himself cleaning the toilets in a lean and efficient fashion. And basically his concept is fix everything you can, even if it's just a 2-second improvement, and those 2-second improvements are cumulative over time. That's what allows us to be creative and do interesting things, is by eliminating every little bit of waste we can along the way. They went from a stressed out company that couldn't handle large orders to a company that regularly grills hot dogs at lunch and plays guitar just for fun, because they can get away with it. I'm not going to go into each of these because I see we have 12 minutes left, but these are the 8 wastes of Lean. And if you look at all of your manual deployment and provisioning processes, you will be able to match up steps in that process with all of these 8 wastes. Especially stuff like unnecessary human motion and underutilized talent. The fact that we have senior system engineers that are doing things manually means they are not working to their peak potential. And in terms of virtualization, that also goes for deploying on physical hardware in some cases. I've known senior engineers that have to spend days untangling patch cables in a data center because remote hands made them messy. And senior engineers shouldn't be doing that. They should be designing systems that customers actually care about. And no customer cares about patch cables. Let's make sure this video, okay. So this is a video. This is 67 seconds of the slowest pit stop you will ever see. I mean, look at that guy, wailing on that tire with the hammer. He's still on tire 1. All right, first tire's off. First replacement tire is on. We got this guy in the back just standing there. I don't know what the guy in the black hat is doing. wailing on tire 2. Nobody's touched the back tires. All right, second replacement tire's on. Oh, here we go. Almost done. If I had the audio hooked up, you would hear the narrator say, and in just 67 seconds, they are out of the pit. So let's check out what a modern pit stop looks like. Notice that we've gone from 4 people in the pit crew to 18. Some of you might be saying, this is a terrible analogy. Like, I can't afford to have 18 people doing anything. In the context of our work, these are not people, these are computer processes. Here we go. Don't blink. And they're off. So that's the sort of thing that 2 seconds of cumulative improvement can do over time. Like, we can go down from a 67-second pit stop to under 5 seconds. So let's talk about some more common complaints that we might hear. Some of you might be saying it's 2015, and I'm pretty sure Docker solves all of this. Why are we talking about virtual machines? Docker is totally awesome, but you are awesome even if you are not using Docker yet. Not all applications are ready to run on Docker, and not all production environments are tooled to run Docker containers. So not much is actually revolutionary. Most things are evolutionary. And if you're not yet deploying Docker in production, and if you're still using handcrafted system images that never get updated, the act of going through this process of getting good at this will allow you to then be ready to move to Docker when it's time. None of your effort in this case will be wasted. Some of you might be saying, how can we trust automatically built machine images? That's scary. We do everything by hand. So your automated tests aren't sufficient, but you are not alone. Like, it's natural to be afraid if you haven't done this in an automated fashion, but there is no time like today to start building an automated test suite so that you can get comfortable with automated system builds. The fact that you have taken time out of your week to come to this conference means that most of you are probably comfortable with automated tests. Automated test comfort, folks? All right, hands. If you're not comfortable yet, if you know friends and family that are in test roles and they aren't comfortable with automated tests, don't beat them over the head with a stick about how they need to learn how to automate or they're going to die. Like, we can bring people along into this world of automated testing and level their abilities up so that they can do more value-added things for our customers. But it's not going to work if you just yell at them. One really brief anecdote while I have time. Has anybody read the book The Box? It's actually about shipping containers. Interesting thing, when containerization actually happened, of course, we were moving away from break bulk shipping, where people were manually taking bags of rice and tires off of ships one at a time. And the dock workers freaked out at the idea of large 20 to 40-foot containers being taken off of ships in a single minute by a crane. And in their labor negotiations, they argued that you guys can do whatever automation you want as long as you hire 21 people per hatch. Even if 20 of those people are standing idle, you have to hire 21 of us because that's what our old contracts said. What they finally landed on was the idea that you can do any automation, just don't eliminate any of our jobs for at least 3 years. And if you eliminate any of our jobs, you have to pay a generous severance and retirement benefits for those guys that no longer have jobs on the docks. The incredible thing was, because of the efficiency that was brought about by containerization of cargo, no dock workers were laid off, and as a matter of fact, they had to hire a ton more to deal with the increased load at the docks. Because shipping became so efficient and ships weren't spending a week getting unloaded and reloaded, we were able to ship a lot more, and that's why today we can cut down trees in the United States, send them to China for milling, and then send them back. It's just not a factor of production anymore to think about shipping. Similarly, as we become more efficient, we're not going to lose any jobs. Like, there is a ton of software yet to be made. There is a ton of improvements to be made to existing software. Don't let this automation stuff freak you out. And if you have friends that are freaked out by the automation stuff, help them become comfortable with the idea that there's more than enough work to go around. And hopefully this talk has showed you how to do a little bit of that automation work yourself in the context of system builds. If you guys have any feedback at all, we have about 5 minutes left. I accept questions, comments, angry rants, and favorite bread recipes. You can hit me up on Twitter or email, and I open the floor to questions if you guys have anything. Looks like we have exactly 5 minutes left. All right, let's go eat then. Thanks, guys.